Okay, so let's look at the converse of this theorem. Converse kind of means I say it in the opposite direction. Okay, so here we said we had a circle, and we said we went from the center of the circle to the center of a chord. This time we're going to say we're going from the center of the circle and we are going to draw a line perpendicular to the chord. And this theorem says, so if I have O, A, B, M, this theorem says a line drawn from the center of a circle this time we don't draw it to the center, we draw it perpendicular, and the result is it will bisect the chord. What bisect means is I divide it perfectly in half, not chord. Sorry. Okay, so in other words, this one says if I draw it perpendicular, then it will meet the midpoint of AB. Can you see how it's a little bit how we're saying it in a different way? Does that make sense? Okay, but this time we don't know that AM is equal to MB. That's the conclusion. In the previous one, we knew it was given that AM is equal to MB. Okay? And the conclusion was it's perpendicular. This time we make it perpendicular and the conclusion is it is equal. Okay, now what is the to prove? So if I have to prove this, what do I have to prove according to this? Good, that AM is equal to MB. Okay, I'll do the construction for you and then you guys try and do the proof for me. Okay, the construction, same thing. Okay, it's a little bit different but the construction is the same. Okay, I'm still just going to construct these two lines. Okay, construct line AO and OB. Okay, so you go ahead and do for me the proof, which was very similar, okay, but a little bit different. Okay guys, I'll go on. So what we have is that we want to obviously show these two triangles to be congruent. Okay, OMA is congruent to OMB. That's what I want to show. So I want to show OMA is congruent to OMB. If I can do that, then I know that all of the sides are equal, which means that AM would equal to MB. The way I would do it this time is this time I see I've got 90 degree. Okay, so if I do have perpendicular, I always look at the hypotenuse. Do we know the hypotenuse? Do we know that this one's hypotenuse is equal to that one's hypotenuse? Why? They're radii. Both of these are radii. They go from the center to the circumference. So yes, so we can use that if we have one more side. What's the other side that we have that are equal? That is it. OM. So let's start with the right angle. So we're going to show RHS, right angle, hypotenuse, and side. So first of all, we say that AMO is equal to BMO is equal to 90 degrees. That is given. We were told that it is perpendicular. So that's given. Secondly, we have that AO is equal to BO or OB, and that's because they are radii. You should actually say of the same circle, but radii should be accepted. Okay, thirdly, we know that OM is equal to OM for the simple reason it's a common side. And therefore we have all the conditions to make these two triangles. So that's why I would say therefore triangle AMO or OMA, however you want to write it, or OAM, doesn't matter, is congruent as long as you stick with the angles. The order of this here should reflect in the order of this here. So since M is the 90-degree angle and we have him in the middle here, it must be in the middle here. Okay. Since this angle O is equal to that angle of O, okay, if O is at the end here, O must be at the end here. Okay. And then obviously the B, that means A and B are equal. And that's what we see there as well. Okay, so we have that, and now we must put our reason. Don't forget to reason, otherwise you get no marks. The reason is RHS. We've shown the right angle, the hypotenuse, and the side are all equal. And then finally, our conclusion is because these two triangles are exactly the same, it means that they're corresponding sides. This side AM, you see the first two letters here, is equal to that side BM, the first two letters there. So that comes from congruence. AM is equal to BM.